Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 10, Interpreting Quadratic Functions from the Graphs and Tables. Okay, classwork example 1, it says, in a study of activities of dolphins, a marine biologist made a 24-second video of a dolphin swimming and jumping in the ocean with a specially equipped camera that recorded one dolphin's position with respect to time. This graph represents a piecewise function, y equals f of t, that is defined by quadratic functions on each interval. It relates the dolphin's vertical distance from the surface of the water in feet to the time from the start of the video in seconds. Use the graph to answer the questions below. Okay, so piecewise function. Here is a quadratic function that goes from here to here. And so a would be negative because it's got a maximum and it's opening downward. But then from here to here, the next piece of the piecewise function is a quadratic function where a is positive. So it is opening up and it has a minimum which means it dove to a certain depth. What is that? 40, 20, 1, 2, 3, 4. All right, so 44 feet, something like that. And then it came back up. This is the surface of the water, the x-axis, or in this case, t-axis, time, is here. And this is the height of the dolphin h. So we don't have an xy, we have an ht. Okay, so this is the next piece. And from here to here, it is a quadratic function where a would be negative. It has a maximum height here, a little over 20 feet high in the air. Okay, so a says to describe what you know for sure about the actions of the dolphin in the time interval from 0 to 6 seconds. So here is the 6-second mark. So here is the 0 mark. So it's asking what happened between that. Describe what you know for sure about the actions of the dolphin. Well, if this is the water level, height of the dolphin in feet, distance from the water, 0 distance from the water means you're at the surface. It is out of the water here. It jumped up, it reached a maximum here, it pulled back down and landed into the water at 6 seconds. Okay, can you determine the horizontal distance of the dolphin traveled in that time interval? Okay. In other words, as it was swimming, it jumped. It's asking if this graph shows how far it jumped from one point in the water. So it came out of the water at a certain point and landed in the water at a certain point 6 seconds later. Can we tell the horizontal distance the dolphin traveled? And the answer here is no. This is a distance in height out of the water. How much did the dolphin go up over a period of time? And then how much did it stay underwater for a period of time? It does not tell us how far it went. Okay. B, where do you find the values for which f of t equals 0? Explain what they mean in the context of the problem. So the values for which f of t equals 0, y equals f of t is 0 at the 0-second mark. So that's f of 0 equals 0 right here. F of 6 equals 0. And then right here, that was f of 6 right here. This is f of 16, and that equals 0. And then right here, f of 24. Equals 0. So what that means is at the time 0 we were at the surface of the water. At the time of 6 seconds we were at the surface of the water. At 16 seconds we were at the surface. And at 24 seconds we were at the surface. So f of t equals 0, f of whatever time equals 0 means that That is when the dolphin left the water or re-entered the water. That is when it was at the surface. Part C says, how long was the dolphin swimming underwater? Underwater means below the x-axis. Okay, or in this case, the t-axis. So when was it below? Well, it jumped and it landed in the water here. It was below this whole time here, and then it came back to the surface at this time and jumped. So at 6 seconds, it entered the water, and at 16 seconds, it jumped out of the water again. So it was below, it was swimming underwater between 6 and 16 seconds, and so 16 minus 6 equals 10 seconds. And that is when f of t is less than 0. Okay. D says, estimate the maximum height in feet that the dolphin jumped in the recorded 24-second time period. The maximum. Okay, well, there's a relative or local maximum here. I don't know if that's been discussed yet. Okay, but that is not the absolute maximum because this point here is higher. So it jumped, swam underwater, came back, jumped even higher than the last time. So this is our highest point during the whole interval from 0 to 24. Okay, so if I got my ruler out, and drew a line right here, this height here is higher than this height here, so this is the height we're looking for. So x or t is 20 seconds, and the height is approximately, well, if this is 0, 5, 10, 15, 20, 20, I'd say approximately 24. There we go with my 4s again. Okay, approximately 24. Estimate the maximum height, and I would say approximately, okay, height is approximately 24, and height of the dolphin in feet. Part D says, locate the point on the graph where f of t equals negative 50. So f of t, here's negative 40, negative 45, negative 50 would be right here. And explain what information the coordinates of that point give you in the context of the problem. So f of t equals negative 50 is at the point 11, comma, negative 50. In the context of this problem, that means, let me type this, I would say after or at 11 seconds, the dolphin DOLF, that was good. At 11 seconds, the dolphin was swimming at a depth of 50 feet, or it was 50 feet below the surface at 11 seconds. Okay. Okay, example 2 says the table below represents the value of Andrew's stock portfolio, where V represents the value of the portfolio in hundreds of dollars. Okay, so that means that this is a lot of money. So if this is in hundreds of dollars, that means this is 325 hundreds, which is $325,000. Okay? And T is the time and month since he started investing. So 2 months after he started investing, we weren't told how much he started with, but he's got at $325,000. Then after 4 months, 2 months later, he's at 385. So he's made $60,000 in 2 months, which isn't too bad. Okay, and it continues on. Now, if we were to make a conjecture, it says answer the questions that follow based on the table of values. A, what kind of function could model the data in the table? Well, 2, 4, 6, 8, 10, 12, 14, 16, 18. T is continually increasing. This is going up, it's going up, it's going up, it's going down. Oh no, it went down here. So it's increasing here, increasing here, increasing here, but then it took a dip here, and this value matches that value, and it dropped again here, and this value matches that value. So at that point, I would say this looked like a vertex, and this is repeating from one side to the other, but I'd have to continue looking at this. So I graph this. Let me pull this up. And this is what the graph of those points look like. I'll move it right here. Okay, so this is after 2 months, and we're at $325. Then 4 months, 6 months. This line right here I drew would be the axis of symmetry. C is our vertex, 406, 405. And then it starts to drop. Okay, and he went all the way down to being in debt. This is the $0 mark. So now he is in the hole, $315,000. Okay, so he just lost the value of a house almost, depending on where you live. Okay, so looking at this, yes, it does look like a quadratic, but we cannot say for certain that every U-shaped curve looks like a quadratic, but in this case it does, because it appears we have a vertex and our values are symmetric about the vertex up until this point here. Part B says, assuming the data is in fact quadratic, how much did Andrew invest in his stock initially? Explain how you arrived at that answer. So if I bring that graph back up, we weren't told his initial value, but if this is definitely a quadratic function, okay, let me grab this. And I'm trying to move it somewhere where I can. Okay, there, it's better over here. Okay, so at 2 months, we are here. 4, 6. Okay, so D is a reflection of B. E and A reflect. So F should be our reflection back to here. So if I had another dot, I don't know if I can draw in this. I'll try. I don't think so. So if I had another dot over here mirrored across F, it looks like it would be right here. And F was 1, 2, 3, my vertex. Then 385 was D, 325 was E, and this was my F right here. So it should be initially, he started out with $225,000, which would be right here. Okay? So that's what I would say. Assuming this data is a quadratic, how much did he initially invest in his stock? I'd say $225,000. Explain how you arrived at that answer, and it would be because that would be the symmetry of this point, 12 months. 225 would have been up here, 0, 225. C, what is the maximum value of his stock and how long did it take to reach the maximum value? So if I go back, the maximum value of his stock was $405,000 and it occurred at the 6-month point. So if I wrote that as an answer, I would say 6, comma, what was that value? 405. Okay, so that means it took him 6 months to get up to $405,000. D says, if the pattern continues to follow the quadratic trend shown above, do you advise Andrew to sell or keep his stock portfolio, and explain why? Well, if the trend is continuing, then what's going to happen here is, if the trend continues, this is just going to keep going down, 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 and he's going to go into deeper and deeper debt with his broker. So he will become broker. Ha ha. All right, so if it continues, he definitely needs to bail. He needs to get out of whatever he's in, because it is definitely going south, and that is not something. And see this house right here? He's going to lose it if he keeps going. All right, E. How fast is Andrew's stock value decreasing between 10 and 12? How fast is it decreasing between 10 and 12? Well, it decreased. It went from 325 to 225. So I'm going to write that. 10, 325, 12, 225. And let me double check my values. 10, 325, 12, 225. That is correct. So now it's saying, how fast is Andrew's stock value decreasing? So if I take my f of b minus f of a divided by b minus a, I get f of b, 225, minus f of a, 325, divided by b, 12, minus a, 10. And that would equal 225 minus 325 is a negative $100,000 over a 2-month period, which is a $50,000 per month loss. Then it says, find another 2-month interval where the average rate of change is faster than 10, 12. So if I go back, so we just did this one, and it was a drop of 100,000. Well, all I have to do is go to the next one, 12, 225, 1485. So now I have 12, 225, comma, 14, 185. Is that right? No, 1485, no 1. So again, if I do the f of b minus f of a, that'd be 85 minus 225 divided by b minus a, which equals, hey Siri, what's 85 minus 225?
85 minus 225 is negative 140.
Divided by 2, which equals negative $70,000 per month. Okay, so in the interval between the 12th and the 14th month, the rate of his loss was more. He lost $20,000 per month more between the 12th and 14th month. F says, are there other 2-month intervals where the rate of change is the same as 10, 12, and explain your answer? Well, if this is a quadratic function, remember that the rate of change will be equal on either side of your axis of symmetry. So if I drew a line, let me pause this and do it behind the scenes. Okay, so it says, are there other 2-month intervals where the rate of change is the same as between 10 and the 12-month period, and explain your answer? So what I did was drew a line, because our rate of change is a linear function where the slope is the rate of change. And here is the two intervals, here and here. Can I move that line anywhere on this graph and connect two other points? And the answer is no. There is nowhere else I'm going to find that rate of change the same. Okay, so the rate of change here is this slope, if you will. And if let me copy it so I don't have to move it. Okay, so there is a copy. So can I move this anywhere else on the graph and find the same rate of change between 2 points? And it looks like maybe from C to H. And it looks like B to I. D to G, C to H, B to I. So it looks like the rate of change is the same as we go out these months. That's really interesting, isn't it? Now looking back at this, are there other 2-month intervals? So there aren't any other 2-month intervals. There's longer intervals. Okay, this interval here is a distance of 4 months. This is 6 months. This is 8 months. But there are no other 2-month intervals. In other words, between 2 points that has the same slope or rate of change. So the answer is no. That is the end of lesson 10. Review the lesson summary and go do your problem set.